Hey everybody, Mr. Judson here. So, yeah, you're probably looking over my shoulder here and reading this long division and going, oh my gosh. Yeah, nobody likes long division. But unfortunately, we need to know how to do long division with polynomials. It's something that happens, we'll use it here in pre-calc, but we'll also use it next year in calculus. And so that's what we can look at for today. Now, if we go back to the kind of long division we've done in the past, you guys would look at this and say, now first of all, I'm okay with doing this kind of stuff on the calculator. None of us would ever do this by hand anymore, right? We would just divide on the calculator and get our answer quick. Because that's kind of what math is about. We learn how to do things quicker as time goes on. But it's the process that we need to make sure we remember to help us get through this problem. All right? So I just want to take a look at the process. When I divide this, the first thing I say is 5 goes into 14 how many times? Twice. Okay, so I put a 2 up here, and then I would go back and multiply, get 10, and then subtract. As soon as I subtract that, I get 4, and I bring down the next number, and then I repeat that process. That right there is the way we want to think when we do this problem. How many times does this go into here? Twice. Okay, now multiply. You get 10. Subtract what you've got there. Once you do the subtraction, bring down the next number. Now I look at that and go, well, 5 goes into 42 8 times. So I multiply, I get 40, subtract, bring down the next number. And we keep on going. I'm going to work this to the end. 5 now goes into here 5 times. And so I multiply, I get 25. We subtract that. And then there's a couple different ways we can write that remainder. I could just say remainder 4. But the way that makes the most sense is to say 285 and 4/5. Okay? It's kind of like if I was doing 16 divided by 5, I would get 3, and there's still 1 left over, so 1/5. I'm doing that same type of thing here. Okay? I want to write my remainder as a fraction where this is the numerator, this is the denominator, 4/5. All right? So now I want to transfer that knowledge over to this problem. And it's a little bit different, so we've got to make sure we understand. When I say how many times does this go into here, really I'm only looking at the first term, and I want to know how many times does x go into 5x cubed. Now, when we ask that question, how many times does x go into here? Another way to say it is x times what equals this. Right? If I just divide this by x, I get 5x squared. And now what do I do after I write something up here? I then multiply. So now what I'm going to do is I'm going to distribute that 5x squared to both of these terms. So when I multiply, I get 5x cubed. I want to get the same thing because I want to subtract it and have this go away. Plus 20x squared. And now I need to subtract. That's what we did here, right? Here's where you got to be careful though. People look at this and they go, okay, that minus that is 0, and that plus that, I just changed from subtraction to adding, right? I have to say that minus that, so 3x squared minus 20x squared is a negative 17x squared. And then just like we bring down the next number, we now bring down the next term, minus 8x. So now how many times does x go into that term? Or x times what equals this? Well, a negative 17x. Right? That's how many times x goes into here. When we say how many times does this go into here, what we really mean is a negative 17x squared divided by x. If I just write that in a different color here, negative 17x squared divided by x, this x cancels with one of these, and there's my answer. I'm going to write it right here. Okay? All right, so now I need to multiply back. So a negative 17x times x, that's a negative 17x squared. Take it times this term. So 4 times 17, what is that? 40 plus 28, negative 68 x. And then I need to subtract that. So when you subtract a negative, you get negative 17x squared plus 17x squared, that's 0. I'm going to subtract a negative here, and so what I get is negative 8x plus 68x. That would be a positive 60x, and then I bring down the next term. All right, so how many times does x go into here? 60 times. Right? If I write 60x divided by x, the x's will cancel. So it goes in there 60 times. So when I multiply back, I'm going to get, let me get some more room here. I'm going to get 60x. 60 times 4, that would be plus 240. And then I need to subtract that. So that minus that is 0. 12 minus 240, that's going to be a negative 228. And I had just brought down my last term, so this is now my remainder. And what I want to do is I want to write that as minus 228 over x plus 4. Just like I wrote this, 4 over 5. When you write a mixed number like this, that really means 285 plus 4/5. Or if I write something like this, that means 3 plus 1/5. Okay? So what we're saying here is we've got this answer plus a negative 228 over x plus 4. We're not going to say plus a negative because that really just means subtraction. And there it is. There's my answer to that division problem. So here's the thing. I told you guys we're going to learn something called synthetic division. And you'll like it. It's a lot better than this. But there are times where you can't use synthetic division. You have to use long division to get your answer. And so we need to know this. It's not one of those things we can look at and go, oh, I don't like this. I'm just brush this aside. I'm just going to ignore it. No, we got to know it, all right? And we'll have to know it next year in calculus. There's some things we do where we have to do long division to make a calculus problem work. All right? So let me give you guys one to try. All right, so I'm going to try and help you guys get started on this one because there's a couple of things we got to be careful of. So first of all, when we say this expression divided by this, whatever you divide by, that's what you write down first when you do a division problem. All right, so I should write this down as we're dividing by 2x plus 1. The proper way to say this is whatever's inside here, I say that first, and then divided by this. But I got to be careful when I write this down. Once you start with a certain exponent, you need to have something for every exponent on down. All right? So we're going to have 2x to the 4th. There is no x cubed term, so I'm going to put plus 0 in there, just as a placeholder. And then plus 3x squared. And then plus, there is no x term, so another 0. And then minus 8. That's the division problem that this is asking us to do. So you guys go ahead and try this. I'll give you a second. All right, so let's work our way through this together. So first of all, 2x goes into here how many times? In your head, just picture, I'm dividing this by 2x. The 2's cancel, 1x cancels with an x, that's x to the 3rd power. All right? All right, so 2x goes into there, x cubed times. Now I need to multiply. So I'm going to get 2x to the 4th plus x cubed. And then I have to subtract. That minus that equals 0. Always has to equal 0. If it doesn't, I did something wrong. And now this minus that would be a negative x cubed. Bring down the next term. Okay? 2x goes into here how many times? Oh, this is going to start to get messy. I'm dividing by 2x, so that x will cancel with one of these, but what I'm going to get is 1/2 x squared. Negative 1/2. So negative 1 over 2, and then this divided by this is x squared. So all of a sudden we got fractions showing up. They're numbers, right? We've got to be able to work with it. All right, so let me take this out of here. So this goes into there, negative 1/2 x squared times. I now need to multiply back, so half times 2 is 1. X squared times x is x cubed. And a negative times a positive is negative. And then I multiply times this one, I get a negative 1/2 x squared. And now I'm going to subtract that. So when you subtract a negative, that becomes positive. Add it to this, you get 0. That becomes positive. 3 plus 1/2, that would be 3.5 or 7/2 x squared. Bring down the next term. So now 2x goes into there how many times? Well, let's go off to the side and write some things. 7/2 x squared divided by 2x. I know this x will cancel with one of those, so this is going to equal something x. If I look at the fractions, I've got 7/2 divided by 2 over 1. That's 7/2 times the reciprocal, and that equals 7/4. Okay? To do a fraction divided by a fraction, you got to flip the one you're dividing by over and multiply that. So that's what I get when I take this and divide it by 2x. 7/4 x. So plus 7/4 x. Alright, so now I need to multiply back, so I'm going to do 7/4 x times 2, which I know it should give me the exact same thing, right? That keeps on happening every single time. So I'm not even going to think about that, I'm just going to write it down. And then 7/4 times 1, or 7/4 x times 1, that would be plus 7/4 x. And now I need to subtract that. So that minus that is 0. That minus that is a negative 7/4 x. Bring down the next number. So how many times does 2x divide into that? This is hard to keep all this stuff straight in your head, right? That's why I keep on going over and just writing some stuff down. A negative 7/4 x divided by 2x. Alright, that x cancels with that x. This is really 2 over 1, so if I flip it over, I would get a negative 7/8 when I multiply that. So minus 7/8. So now when I multiply back, I know I get the same thing. The negative 7/4 x. And then when I take that times this, so a negative 7/8 times 1, that'll be a negative 7/8. And I have to subtract this. I'm getting down to my remainder. So this becomes positive, so that plus that equals 0. This becomes positive, so I've got a negative 8 plus 7/8. A negative 8 plus 7/8. What does that equal? Well, a negative 8, if I convert this to 8s, think of this as 8 over 1. If I want to convert to 8s, I'm going to have a negative 64 over 8 plus 7 over 8. There's my common denominator. Negative 64 plus 7, that's going to be a negative 57. So a negative 57/8. There's my remainder. And so what I want to do is I want to say minus that over whatever I'm dividing by. Minus 57/8 over 2x plus 1. And I wouldn't call that really simplified because it's a fraction within a fraction. It's a complex fraction. So how do we divide that? Well, if you think of this as 2x plus 1 over 1, I need to flip this over and multiply. So really that 2x plus 1 just gets multiplied by the 8. So I could rewrite this as a negative 57 over 8 times 2x plus 1. Still not completely simplified. I could distribute that 8 and I could call this 16x plus 8. So if I did that, whoop, 16x plus 8. Now I've got an answer. Whew! That was an ugly one. All right, long division. Let's try one more. Hey, I think I heard that. I think somebody saw this and might have slipped out a cuss word. Yeah, this is pretty ugly. It's kind of scary looking. But the process doesn't change. I think that's one of the most important things to learn in pre-calculus. The process doesn't change. I just got to crank my way through it, okay? So I'm dividing by this, which means I want to write that part first. X squared plus x minus 1. Inside here I've got 4x to the 5th. There's no x to the 4th, so plus 0. Plus 3x cubed. There's no x squared, so plus 0. And then plus 2x. All right, so let's just do this together. So x squared would go into here how many times? Just kind of think it in your head as we talk about it. I should have right here 4x cubed. All right, so then I multiply back. I get 4x to the 5th plus 4x to the 4th minus 4x to the 3rd. And I need to subtract this. So that minus that is 0. That minus this would be a negative 4x to the 4th. When you subtract a negative, this becomes positive. So it'd be 3 plus 4, that's 7x to the 3rd. Bring down the next term. I think the hardest part of this whole problem is doing the subtraction and keeping the sign straight. You guys will find this out. The most frustrating thing, and maybe somebody's already done it, is you get to the end and realize you missed one sign at the very beginning and it screwed up the whole problem. That's the most frustrating thing about this. All right, so now I want to say that x squared goes into here how many times? Well, if I divide by x squared, just kind of picture it written there, I'll still have negative 4, but 2x's here will cancel with these two, so I get a negative 4x squared. Now we multiply back. Negative 4x to the 4th, minus 4x cubed, and plus 4x. Now I'm going to subtract. So opposite of that is positive, negative 4x to the 4th plus 4x to the 4th, that's 0. Opposite of this is positive, so 7 plus 4, that's 11x to the 3rd. Opposite of that is negative, so 0 minus that would be a negative, whoops, that should have been squared. 4x squared, bring down the next term. All right, so x squared goes into here how many times? 11x. Multiply back, we get 11x cubed plus 11x squared, and then minus 11x. And now I have to subtract. So that minus that is 0. Negative 4 minus 11, that's a negative 15x squared. And 2 minus a negative 11, so that means 2 plus 11, that would be plus 13x. As long as this exponent is equal to or less, that means I can keep on going. I don't have to bring any more numbers down, but I do have to keep on going with this. So yeah, one more step. X squared goes into here. If I was to divide this by x squared, those x squares would cancel. I'd be left with negative 15. So a negative 15. When I multiply that back, I get a negative 15x squared, negative 15x, and then a negative times a negative, that'd be a positive 15. Alright, now I think I'm almost done. So when I subtract a negative, that becomes positive. These add up to 0. I'm going to do 13 minus a negative 15. That means we're going to add this. So that'll be 27x. And then 0 minus 15. There's my remainder. So 27x minus 15. Since that first term was positive, I'm going to say plus 27x minus 15 over this. X squared plus x minus 1. There's my answer. Yeah, in terms of showing work, nobody can do this in their head. Not even close. I can't even imagine the brain that could do this in their head. Can't even imagine. All right, you guys, that's what we have for today. Not a very exciting assignment, but something that we need to know how to do. That's all we're doing is long division. You know, I can tell you if you put this off until Sunday after Thanksgiving, you may have to watch this video again. I'd probably at least try and do a few problems, take a couple days off, do a few more, take a day off, and finish it up on Sunday. All right, let me get you guys an assignment. All right, here we go. Assignment number 11, week 11. This will be our only assignment this week. All right, don't forget, last week's stuff, we got to make sure and turn that in on Wednesday. All right? This is going to be due the Wednesday after we get back from Thanksgiving. Probably shouldn't have said that. Some of you are probably going, yeah, I'm putting this off until Tuesday. Wednesday at 10. Okay, Wednesday at 11, I'll do it in an hour, Judson. Don't do that. Page 159, we're going to do 8, 9, 13, 15, and 17. All right, long division. We're only doing a few problems because these take a while to get through. But I don't think we need to do 20 of them. Doesn't make sense. We just need to do enough so we get the idea. All right, you guys, there it is. Enjoy your time off. Have a good break. Wish your family the best. Stay safe, all right? Bye.